Today we are going to talk about principle of superposition. There are the large number of charges placed in a system. Every charge is acted upon by other charges. Every individual charge is acted by so many other charges placed in its surrounding. Principle of superposition help us to find out the net force acting on a single charge due to multiple charges placed in a system. Today I am going to talk to you how to find out the net force acting on a single charge due to multiple charges placed in a system by using principle of superposition. We know that whenever two similar charges placed together, there is a repulsion between them and there is an attraction between two dissimilar charges. The magnitude of force of attraction or the magnitude of force of repulsion can be obtained by using Coulomb's law. First of all, we will be considering only two charges and we shall be drawing the vector diagram for the repulsive forces and the vector diagram for attractive forces. Number 1, we consider both charges are of same sign. If both charges are same sign, Q1 into Q2 will be greater than 0. That is, product of charges is positive when both the charges are having same sign. Now let us place the two charges. First of all, the charge Q1 is placed here and the charge Q2. Both are positive. Now consider origin O. Now draw the vector diagrams from origin towards Q1. So the vector R1, that is the position vector of Q1. The vector R2, that is the position vector of Q2. You also notice that arrow marks are away from origin towards the charges Q1 and Q2. Now we have to draw the vectors from charge Q1 to charge Q2. So the vector leading from charge Q1 to charge Q2 is denoted by vector R21. Similarly, the vector leading from charge Q2 to charge Q1 is denoted by vector R12. Now, unit vector in the direction from charge Q1 to charge Q2 is given by R21 cap equals to vector R21 divided by magnitude of vector R21. Similarly, the unit vector in the direction from charge Q2 to charge Q1 is given by R12 cap equals to vector R12 divided by magnitude of vector R12. Now, because both the charges are positive, there is a repulsion between them. They move away from each other. Thus, there are the two forces acting on both the charges and these forces are acting in opposite direction. These forces are denoted by vector F21 and vector F12. Vector F21 is nothing but force on Q2 due to Q1 and vector F1 is nothing but force on Q1 due to Q2. Thus we have seen what exactly happens when two similar charges brought together, how the repulsive forces acts on them and what are the different position vectors and how the repulsive forces move away from one another and the direction of the repulsive forces. Let us draw the entire diagram once again in a single stroke. we had two charges. One is the Q1, another is the Q2. We had two charges and it was the origin O. Now what we have done, we joined the origin with the charge Q1 and it was a vector R1, and here is the charge O to Q, Q2 we have joined, that is the vector R2, and both the charges are positive, therefore there is a force of repulsion and the charges are moving in the opposite direction like this, and this was the force F21 vector and this was the force F12 vector. And now join this one, there was the two vectors are there, one is the R12, another is the vector R21. Now, so this is what the summary of entire story I just told you with the help of animation. I would like to tell you one thing, that be careful when you are reading different textbooks, because in every textbook these denotations are not same. What denotations here I am using are specially as per as the NCERT textbook. Now here I can write the expression for F21 vector F21, that is nothing but 1 upon 4 pi epsilon naught Q1 Q2 upon R21 square multiplied by unit vector R21, and F vector F12 is nothing but 1 upon 4 pi epsilon naught Q1 Q2 upon R12 square and multiplied by the vector R12. Here we are multiplying each expression with the unit vector. Whenever we multiply a scalar with the unit vector, then we get the entire vector. For example, I am having this AB and the unit vector is A1 cap and the magnitude of AB nothing but phi. Then vector AB is equal to phi into unit vector. Then I get the entire vector. If I just multiply the magnitude and the unit vector, we get the total vector. So this is what the fundamental concept. So here we had F12 and F21. By using this idea, now we can go for the expression for superposition, the principle of superposition of the charges. Now before proceeding, let us understand what exactly the principle of superposition. Now we have to define principle of superposition of charges. For that, we consider charge Q1. We consider n number of charges, and all charges are assumed to be the point charges, and all charges are placed in vacuum. So I am having the charge Q1 and the charge Q2, charge Q3, charge Q4, and so on, charge Qn. These many charges are placed in vacuum, and there is a force on Q1 due to every other charge. That means there is a force between Q1 and Q2, there is a force between Q1 and Q3, there is a force between Qn and Q4, and there is a force between Q1 and Qn. So every charge is acting some force on the charge Q1. So there is a force on charge Q1 due to every other charge. If you want to find the total force acting on Q1, then that single force, that is the total force acting on the charge Q1, is obtained by principle of superposition. When n charges are placed, the Q1, there is a force on Q1 due to every other charge is acting. For example, vector F12 due to the force on Q1 due to the charge Q2, F12. Similarly, due to the charge Q3, that is a force acting F13, and due to the charge Q4, the force is acting vector F14, and so on. Vector 1n is acting on the charge Q1. summary, there are many charges placed in the vacuum. So whenever you want to apply the principle of superposition for a given charge, for example, we want to apply the principle of superposition for the charge Q1, then we calculate the force acting on the Q1 due to the rest of the charges. How much force acting on the Q1 due to Q2, how much force acting on Q1 due to Q3, due to Q4, and so on due to the Qn. Now here we assume that the resultant force acting on the Q1 is F1, the resultant force due to all the forces. So the vector F1, is the addition of all the forces, that is vector F12 plus vector F13 plus vector F14 plus vector 15 and so on. Addition of all the forces will provide you the resultant force acting on the charge Q1. This is nothing but the principle of superposition of charges. Here I would like to clear one thing. The force between Q1 and Q2, the force between Q1 and Q2 is unaffected due to presence of other charges. That is, the force between Q1 and Q2 is not affected due to the presence of Q3, Q4, Q5, etc. Similarly, the force between Q1 and Q3 unaffected due to presence of other charges like Q2, Q4, Q5, etc. This is the important condition while you use principle of superposition. Therefore, vector F1 equals to 1 upon 4 pi epsilon naught Q1 Q2 divided by R12 square and R12 cap plus 1 upon 4 pi epsilon naught Q1 Q3 upon R13 square multiplied by R13 cap plus and so on 1 upon 4 pi epsilon naught Q1 Qn upon R1n square multiplied by R1n cap. Therefore, vector F1 equals to 1 upon 4 pi epsilon naught taken common Q1 Q2 upon R1 square R1 2 cap plus Q1 Q3 upon R13 square multiplied by R13 cap and so on Q1 Qn upon R1n square multiplied by R1n cap. Now taking Q1 common, so we get Q1 upon 4 pi epsilon naught. Here we get Q2 upon R12 square multiplied by unit vector R12 cap plus Q3 R13 square multiplied by unit vector R13 cap plus and so on Qn upon R1n square multiplied by R1n cap. In summation form, it can be written in simplified form. Q1 upon 4 pi epsilon summation. The minimum value of the charge is starting from 2 here. 1 is the common. Therefore, I equals to 2 and last charge is n. So from starting from 2 to n, and here is a Qi divided by R. One is already common, one is everywhere present, but the other number is changing. Therefore, I, R1I square multiplied by unit vector R1I cap. This is the simplified summation notation, and that is nothing but vector F1. From this we can find out the total force, the net force acting on the charge Q1 due to the rest of the charges placed in vacuum. Here I would like to tell you that the total value of all the vectors, the total force, that is nothing but the vector addition. This vector addition is obtained by utilizing the parallelogram law of vector addition. And what is exactly parallelogram law of vector addition? I already had one video on this channel, so I will provide you the link in my description box. So you just go through that video for better understanding what exactly the parallelogram law of vector addition. Here, to find the total force acting on the charge Q1 is finally obtained by using parallelogram law of vector addition. Now, after going through all this discussion, let us finally define what exactly the principle of superposition is. Definition of principle of superposition of charges. When n number of charges placed in vacuum or in medium, the force on any one single charge due to the number of other charges is the vector sum of all the forces on that charge taken one at a time. The individual forces are unaffected due to the presence of the other charges.